Hello and welcome. So far, we were looking at AI basics in our mini series on artificial intelligence. But if you remember, this channel is about getting all the fundamentals right to build your next product or next startup, or just to have a strong foundation so that you can do well in your work or profession, wherever. So, electronics plays a very fundamental role in building IoT products or building uh, electronic interfaces, embedded programming. So everywhere, electronics is just about everywhere. And there are a lot of fundamentals that needs to be understood well before we can really get something useful out of these concepts. So with that in mind, this is a small mini series which starts right at the beginning of what electronics is and what are circuits, and we go all the way a little bit into sensors, what are digital circuits. We will cover most of the fundamentals required to build your prototypes. So with that said, make sure you subscribe, make sure you like the video. If you like this content, I'll be creating a lot more content on electronics. So stay tuned and let's get into the first episode. So this one is about an introduction to circuit fundamentals. So in the next few minutes, we are going to lay down the foundation of what an electrical circuit really is. Why does it matter? And the core ideas that power everything from a simple light bulb to the devices that run modern technology. So let's get started. What exactly is a circuit? So at its heart, an electrical circuit is simply a closed path that allows electric charge to flow. So if the path breaks, the current stops. So every electronic device you use, from your phone to your laptop, it relies on this very basic idea, a controlled flow of electrons moving through the components. Electronic circuits take this further by using semiconductor based components. So these are like small devices like diodes and transistors, which are used to perform useful operations such as switching, amplifying, computing, storing information, all of this. So let's go into the details of this. So the first one, the three pillars of electronics is charge, current, and voltage. All circuit behavior starts with three quantities: charge, that is the basic building block. This is what the electrons carry through your circuits. Then we have current. It is the rate at which charge flows, like the speed of water moving in a pipe. If there is a big, large pipe, you have more water flowing through that. And then we have voltage. This is the push that drives the charge forward, the electrical pressure. So if you have a pump or if you have a container where you can apply pressure on water, water kind of gushes out of it, right? So voltage is like that. It is the push that drives charge forward. So three pillars: charge, current, and voltage. So if voltage is the why of a circuit, like why is the current flowing? Because there is voltage, there is pressure being applied. Then current is the how of part of it. When we say how, this is how much quantity of charge is flowing around. So modern circuits are built on a very simple rule. Currents flow from higher potential to lower potential. Understanding these three alone already gives you a mental model you need for 80% of our circuit problems. So now let's look into power. Power is the work done by circuits. So when voltage pushes current through a component, it transfers energy. So let's say you have a resistor and you're pushing current, or voltage is pushing current through that. It is transferring energy from one end to the other end. The rate of that energy transfer is called power, and it's calculated by P is equal to voltage into current. So every component in a circuit is either absorbing power like a resistor or supplying it. So there are active and passive elements. If you have a battery, it is supplying power. If you have a bulb, it is absorbing power. So this distinction becomes important when we start analyzing real system, and it also connects directly to one of the most important principles in circuit analysis. The principle is conservation of energy. So every circuit obeys the same rule that governs all of physics. Total energy supplied and the total energy absorbed is zero. So if you have a battery, if it is supplying energy, it is going through the circuits into a light bulb and coming back to the other terminal. The total energy supplied and the total energy absorbed is going to be zero. Nothing appears out of nowhere, nothing disappears. It's all there. So this simple idea forms the backbone of all circuits, laws, and calculations. It leads us straight into two of the most powerful tools in electronics: Kirchhoff's laws. So Kirchhoff's current law. So this is like imagine a traffic junction. Cars come in and cars are going out. but they can't pile up in the middle. It's a junction. Cars need to keep moving. That's exactly what happens in a circuit. Kirchhoff's current law says that the total current entering a node must equal the total current leaving it. No charge builds up, no charge disappears. This rule kind of helps us analyze how current splits and combines across branches of a circuit. If there are 10 cars coming into a junction, 10 need to go out. You can't account for missing cars. So now let's look at the other law, which is Kirchhoff's voltage law. Imagine walking around a closed path and returning to where you started. Your total change in height is zero. Voltage works the same. Kirchhoff's voltage law says the sum of all voltage rises and drops in any closed loop is zero. This is incredibly powerful. You can analyze almost any circuit with this one statement. And let's look at another important property before we kind of wrap up this episode. Resistance and Ohm's law. So real components don't let current pass freely. So if that was true, then nothing would happen. They oppose it. So if you apply charge to any material and try to push your electrons through the material is going to oppose that. And this opposition is called resistance. Ohm's law captures this beautifully. Voltage, which is the water pressure we talked about, where you are pushing water and it's trying to come out of it. So think of that as voltage. Voltage is equal to current into resistance. So when you know any of these two values, voltage, current or resistance, you can always find the third. For example, we talked about the water example. If you know how much pressure you are putting onto a water pump, you know how much water is going to come out of it. That is the current. And if it is passing through a small pipe, you know how much resistance it's going to offer. So if you know any one of these, you can calculate the other two. So we can also combine resistors in different ways. You can have a series resistance where you have multiple small pipes all attached to each other. They all add up their resistances. Or you can have parallel resistances combined to become smaller. So mastering these patterns is the first step to analyzing any real world circuits. So those are the basics. So why does all this matter? So understanding these fundamentals gives you a superpower. The ability to break down any circuit, no matter how complex, into small predictable parts. Whether you are designing hardware, troubleshooting electronics, building IoT devices, or just learning engineering basics, these ideas form the groundwork for everything else. So in the upcoming episodes, we'll take each of these topics deeper. We'll go into diagrams, examples, all of those things. So thanks for watching this introductory episode. Please do like the video, and if you like the series, subscribe. In the next part, we'll be looking at resistors, circuit elements, and a few other things. And by the way, if you like more of computers, do check out our AI series. I talk a little bit about how AI models work, the insides of how an AI model is constructed. So check it out, subscribe, and I hope you enjoy these episodes. Thank you for watching.